Hi, everyone. My name is Mandy. I'm the desktop Firefox front-end engineering intern. I work on making Firefox startup performance faster. My mentor is Mike Conley, and my managers are Patricia, Lawless, and Dolske. Why is performance important? We want our users to have a good user experience. We want to produce a product that is of high quality, and we want to be competitive in the market. Performance has ethical implications as well. Inclusion. By prioritizing performance, we make our product inclusive to as many users as possible around the world, regardless of the hardware device that they use. Performance also has an environmental impact. Performance software reduces the need to do frequent upgrades. If the software application is performing well on a high-end device as well as a low-end device, it reduces the temptation to do hardware upgrades. What do we do? For the last several months, the front-end performance team has been focusing on startup performance. And there's 3 categories of startup performance. So there's cold startup. This is when Firefox starts up for the very first time on the computer. There's warm startup, which is when Firefox is already loaded in the background and it's being put to sleep. There's fresh startup, which is when the user has a brand new profile, and this can happen within cold or warm startup. So our team has been focusing on making each of these startup times load faster. Okay, what did I do? My intern project. I've been working on fixing slow I/O on the main thread. Our team has compiled a list of many places where slow I/O is happening. As you can see on the slide, there's a snippet of the list. It's about 600 lines long, so there's many, many places to improve slow I/O. Some of you may be wondering, what is a main thread? A thread is a sequence of instructions being executed in a program. Threads are a way for a program to divide and conquer an instruction. The main thread is important because it is the first thread that runs immediately in a program. It is a parent of all child threads, and it is the last thread of execution in the program. What is I/O? I/O stands for input-output. For example, I/O devices can be your mouse, a keyboard, the screen. The I/O that in particular I care about is the hard drive and a solid-state disk. Let's understand I/O speed. So one CPU cycle takes 0.3 nanoseconds. 1 nanosecond is 1 billionth of a second. What do those numbers even mean? So we can translate those numbers to a more human-relatable time scale. If one CPU cycle is 1 second, then a solid-state disk I/O takes 2 to 6 days, and a rotational disk I/O takes 1 to 12 months. So I'm going to go through how to diagnose a performance problem. The first step is to profile. A profiler is used to record the activity and the time it takes for a program to complete its instructions. Here is a screenshot of a profile. There's a lot going on in this image, so I'm just going to zoom into the area that we care about. Okay, we can see there's this thing called initialize, and it's taking 140 milliseconds to perform. So this was a performance bug that I worked on. Initialize was being called on startup, and it wasn't necessary. We really need to only read the initialize for the add-ons extension when the add-ons have been updated or the browser has been updated. So I've moved that code to happen later on rather than on startup. Back to diagnosing a performance problem. Step 2 is to further investigate the problem, make a call of whether you think this will make a performance improvement. And then step 3 is to bring your findings, consult the domain experts. So if you want to make a performance improvement and it touches the search code, you can go to the search team and say, hey, I want to do this performance improvement. Is this feasible? Will it break anything major in search? So here are some typical solutions that I took to fix performance issues. One solution is to eliminate the I/O entirely. An example of that is that I put a bunch of code behind a pref. So for users that don't have this pref turned on, then the code won't load at all, but it will for others that do. Another solution is to move the I/O to a different thread. An example of problem I worked on was to fetch country code data on a different thread. I spawn up a different thread, and once it collected that data from the hard drive disk or the solid state drive, then it will return that information onto the main thread, allowing the main thread to do more of its instructions and moving this piece of code to a different thread. Another solution is to defer the I/O until it's absolutely necessary. So that's an example of what I showed in the profiler, where when we don't need to load something on setup, then we can move it to load later on when we really need it. And the last solution is to reduce the impact of I/O by reducing how much it needs to read or write to disk. An example of that is that I cached a directory in order to, once the first time we get that directory, I cached it so we don't have to try to get it every single time. And it's much more efficient to do that if it's already saved in memory. In conclusion, I tackled performance issues in various domains, including search, add-ons, cache report, prefs, and file system utils. There's still a lot to be done. Performance is a continuous work in progress. Some things I learned during my internship. I learned how to work efficiently with a large code base. I learned C++. It was a new language for me. I learned Mozilla's way of writing C++. Memory management. There's XVCOM and XVConnect, which is a pretty old design pattern. I learned a bit about operating systems, processes, and threads. I was inspired by my mentor, Mike Conley, and my peers to start a blog about my learnings. Here it is if you're interested. Last but not least, I would like to thank everyone that I worked with. Special thanks to my mentor, Mike Conley, for your continuous support, encouragement, and your patience to entertain a million questions. Thank you to Patricia and Justin Dolske for your continuous support and encouragement in my career growth. I would like to thank all the wonderful and talented engineers I worked with. Thank you, Andrew Swan, Doug Thaler, Heiss, and Florian. That's it for my presentation. I'm going to open the floor up for questions.
So you mentioned having to contact domain experts when you wanted to fix a performance problem. So did you end up having to contact a lot of different teams during your internship?
So the question was that whether if I needed to contact a lot of different domain experts throughout my internship. Yes, I did, because every performance problem is wildly different from one another. And if I'm working with Crash Reporter, there's a team that focuses on that piece of code. So I would reach out to them. And it was really nice to go to the all hands during the internship because I got to meet a lot of these people that I was trying to do fix performance bugs within like their code base. And it was nice to have that face-to-face interaction, as well as people were just generally like really responsive. When I send them a message, they get back to me really quickly. So I was surprised by that, pleasantly surprised, yes. All right, thank you. Oh, right. One more question.
So on mobile platforms, does the browser start up every time that you, so if you move to a different app, does it start up, go through some sort of startup procedure? Because it always seems really slow loading a tab from another application.
Sorry, could you repeat your question one more time?
So if so does the browser go through startup when it loads a new tab on Android? So if you are loading a new tab from another application, does Firefox close and then reload when you're actually on opening Firefox?
Okay. Is there a question specifically about Android?
Yeah, I'm just curious.
I
if...
focus on.
Okay.
Oh, sorry. I focus on desktop startup performance. So Android performance is a different problem scope.
Okay.
I had a question. You mentioned spawning threads to do the I/O. Does Firefox have a concept of like a thread pool for I/O threads that are ready to take the work, or do you actually have to spawn a thread from scratch every time?
For the problem that I worked on, I spawned a new thread to solve that problem. I'm not 100% sure if there's a thread pool, but that's a good question. I can follow up with you on that. Omar?
All right. Yes, yeah, thank you. Very nice.
Okay, thank you very much.